Hello everyone, we've got the final question on an A-level paper here, so it's a tricky Venn diagrams question, and let's have a look at it. It says, the Venn diagram where P, Q and R are probabilities shows the events A, B, C and D and the associated probabilities. State any pair of mutually exclusive events from A, B, C and D. So mutually exclusive events are ones that cannot occur at the same time. Okay, so there's going to be no overlap, or if there is an overlap, it's going to be 0. So we could say A and C, they don't overlap. We could say A and D. We could say B and D. So any one of those three would be fine. The events B and C are independent. Find the value of P. So if they're stating that B and C are independent, then that means that the probability of B intersection C is the same as probability of B times the probability of C. Okay, so what's our probability of B? It is 0.05, add P, add 0.27. So there's our probability of B. Probability of C is 0.27, add 0.25, add 0.08. So when we times those together, that's going to equal the intersection, which is 0.27, because they're independent. So there's only one unknown in this equation, so we can use this to calculate what P is. So we have 0.27 equals P at 0.32 when we add those two together, times by 0.6 when we add those three together. So in order to work out P, we just divide by 0.6 and minus 0.32. And that gives us that P is equal to 0.13. Okay, so that's part B done. Now, part C, find the greatest possible value of A given not B. Okay, so let's think about that from our Venn diagram. So A given not B. So the probability that something's in A, given that it's not in B, that only leaves Q left for the numerator. Okay, because if we're given not B, it's like all of this in there that I'm indicating now is dead. Okay, so we've only got everything here, and around the outside to choose from. So the probability that's in A, the only thing left is Q. And that's going to be over all these other ones added together that are not in A. So it's going to be over R, add Q, add 0.0, add 0.25, add 0.08. Okay, so that's how we would write it down as an expression. Now, what on earth do they mean when they say the greatest possible value? Well, the issue is at the moment that we don't really know what Q plus R is. We don't really know what Q is, and we don't know what R is, and we don't know how the remaining probabilities are distributed between the two of them. So that's our issue. So what can we say? Well, we know that the only things that aren't known at the moment are R and Q. So if we do 1 take away everything, that gives us what R and Q together adds up to. Okay, so when we work that out, that gives us 0.22. And the interesting thing about this is it really doesn't matter how Q and R are distributed, like whether it's all in Q or all in R, excuse me, because they're still going to add up to make 0.22. Okay, so that's what's useful to know there. So that denominator, that's R add Q, is 0.22. So therefore, it's only the numerator that's going to determine when we get the biggest value of the fraction. And in order to get the biggest value of this fraction, it's going to be when the numerator is at its biggest. And that's going to occur when Q is 0.22. So the greatest possible value of A intersection not B is going to be when Q is 0.22. So we have 0.22 over our R add Q over the other probabilities that we had, and that gives us 2/5. Okay, a little bit of a tricky, definitely quite tricky there, I think. Right, what's next? Okay, the next thing it says, for now we're on D, it says D, given that the probability of B intersection not A is equal to 0.5, find the value of Q and the value of R. Okay, so let's think about this. What does the probability of B intersection not A look like? So not A means everything that's in A is dead to us. So everything's gone that's in A. So it's only in the probability of B. So what's left in B is just P, which we now know is 0.13, and the intersection there. So the only things left in B are that. And it's going to be over not A, so over everything that is not in A. So that is R, that is P, that is the 0.27, the 0.25, and the 0.08. So there they all are in the denominator, okay? Everything that's not in A. And you'll notice, excuse me, that the only unknown in this equation is R, okay? So we can just now swap these two over, because they can swap over. So that gives us that R plus 0.73 is equal to 0.4 divided by 0.5. And from that, we can work out what our R is. And we're going to do that by just subtracting our 0.73. And we do that, and we find out that R is equal to 0.07. So we've got to find out what R and Q are. So now that we know that R is 0.07, and remember that they add together, Q and R, to make 0.22, therefore we can find out that Q must be 0.22 take away 0.07. So Q is 0.15. So that's that next bit done for 3 marks. Oh, we're getting close towards the end of this question now. So the last bit then, it says find the probability of A union B not, or the complement of A union B and the intersection of C. Right, I guess the only way we can think about this is, let's visualize what does A union B not look like. Well, A union B, let's have a look at our diagram. So, oops, there we go. A union B would be everything that's in those 2 circles there, okay? So I'm indicating with the cursor. And the complement of that would be reversing it. So it would just be the 0.25, the 0.08, and the R, okay? Now the intersection of that, so we've only got 3 probabilities left, R, 0.25, and 0.08. And because we've got intersection of C, it can only be the bit that's in everything, those 3, but is also in C. So that is just 0.25 and 0.08. So that rather complicated looking thing boils down just to be 0.33. And then finally, the last mark on the paper, it says use set notation to write an expression for the event with a probability P. Now there's various choices that we've got, okay? So we just want something that is just only, is equivalent to just, P only. Right, so what about if we have that we've got something that's in B and it is also in the intersection of not A and not C. So let's think about that. So if something is not in C, then that kind of gets rid of all of those. If it is not in A, that means it's none of those 2. And if we've got that it's, so that only leaves basically R and P. So if we've got like not A and not C, okay, then that basically leaves R and P. But if we do the intersection of it must be in B and not in A and not in C, then that's a way of getting P on its own. So we can basically say one of the options is to say it is B intersection not A and not C. And you can see I've written another alternative version there. Well, that completes this paper. Quite a tricky question on Venn diagrams there, I thought. I hope you found that helpful, and I'll see you in the next video.